so we're going to talk about this topic over here. And it's honestly not too bad. Unfortunately, it's also an absolute foundation of what we're learning. If you don't know how to find molar mass, you can't do the rest of chemistry. It literally is going to be in pretty much every problem between now and, February, with the exception of balancing equations. And so if you don't know how to balance equations and find molar mass, you're going to basically be in a spot where you can't actually do chemistry. So this is like the Rosetta Stone that translates from being able to talk about chemistry and give names to chemicals to actually using them in a lab. Because without molar mass, you can't really use a substance. There's no easy way to measure a mole. Now, we don't know what a mole is yet, but apparently it's going to do something with this molar mass business. And today's lecture is really just about how in the world do you find the molar mass of something. Now, the good news is this is pretty straightforward, and so it should only take us about 10 minutes to learn. So with that, you've got your notes in front of you. Let's follow along with each step. So the first thing we need to do is actually define molar mass. And a definition for molar mass is going to take a leap of faith because we don't know what a mole is yet. And so we're going to define something in terms of a unit we don't know. So for now, just call a mole a dozen or a gross or some group of items. Ours is just a little bigger than those numbers. It doesn't matter. For now, the mole is the mole. And if that's the case, then we can define the molar mass as this. As the number of grams needed to make a mole. 1 mole, 1 exact mole. So we need to know molar mass because we need it to find the mole. And to find molar mass, you need to know what a mole is. You see that's a chicken-egg problem? We're going to choose molar mass first because I think it's easier and it's going to help us understand the other thing. Now, molar mass, I am going to use a symbol for. That symbol is curly M. It's very important that you don't confuse the units with the symbol. This is not the symbol. It's just a curly M, and it's typed out on your notes for you. This just says this is the molar mass. If you want to talk about the units of molar mass, those would be these. The grams per mole. Don't forget the unit. If there's anything that will go wrong for you this entire chapter, is that you're going to stop putting units on things. It's going to sound really stupid to me. Like, I have to put units on stuff? Yeah, put grams per mole on every single molar mass. And every single time you use this problem, it will make your life easier. I am the laziest teacher in the school sometimes, and you must know this is something I still do. It's required. It's required to make this easy. Without putting grams per mole, you're going to get to the next step in this process and wonder, well, what do I do next? So every single time you do a molar mass, you do it as the grams per mole. Now there's some good news, and for that good news, let's go actually over to the periodic table for a moment, and let's talk about, hey, how do you find the molar mass of an element?
So the good news is you actually know quite a bit about molar mass. We've just not called it that before. We've called it the AMU of a substance. The AMU of a substance and the molar mass are actually related. They're the same thing with a different unit, which may seem a little strange, but that's because you haven't learned what a mole is yet. And once you understand the mole, it'll make pretty good sense as to why. And so we're going to just slowly replace the words AMU with grams per mole. For an element, that's as easy as if I want to know the molar mass of zinc, the curly M of zinc, I'm just going to look at the periodic table and say, oh, it's 65.38. Oopsies. And that's pretty easy. 65.38, that's done. And if I wanted to look at tin, it's 118.71. Now, be important. It's got to be grams per mole. If you don't write G over M after 118.71, you write AMU. I'm going to take off a quarter point. If you don't write anything, I'm going to take off half a point. And it seems pedantic, but I'm going to do that. And of course, for that last one, argon is 39.948 grams per mole. So the molar mass of the periodic table is really easy, and I will ask you those questions on this next test. Hey, how many grams are in 1 mole of argon? Oh, Mr. Neck, I know the molar mass of argon. It's 39.948 gram per mole. Super straightforward, right? All right, let's go back to the board.
So one of the things we need to do is actually learn how to calculate molar mass. And to do that, we need to make a table, specifically this one over here. No, over here. And so we have 4 columns: the element, the number of them in the compound, the AMU of that element, and the product. And just like every table we've done before in chemistry, we're going to multiply across and then add down. Being clear, each time you have a new element, it's going to need a new row. So the first example on your sheet, just below this header thing, asks you to find the molar mass of potassium bromide. So that sheet would look something kind of like this. We have a row for potassium and a row for bromide. And of course, if you look, it's KBr. Since there's no subscript, you know there's one K and one Br. So this one's really easy because, well, you don't have to do any multiplication. But still, let's fill in the chart and use the chart to build muscle memory. So if it's K1Br1, if you write KBr, it would look like this. Now I need to know the AMU of the elements. I would need a periodic table for that, but I don't have one. That's terribly convenient. Okay, potassium, 39.098. Do I really need all those significant figures? Maybe. Depends on the problem you're doing. For right now, I would say like round it to 1 decimal. Don't get lazy, but round it to 1 decimal for now. So 39.098 sounds a lot like 39.1 to me. Then bromine. Bromine has a molar mass of 79.904, so 79.9. And then take their sum vertically. So pretty easy. It looks like this. That's not a final answer. Don't get me wrong. I would give you like most of the credit, but I would take off specifically half a point. Probably because there's no unit. You're going to hear that repeated so many times this chapter. So we need to take this and make it a final answer. And there you go, your first molar mass. Now I'm going to ask you to do the next one on your own. And we've got a couple more to do back and forth. But for those, I don't think we're going to use the whiteboard. Let's go ahead and do them on a computer screen where it's a little more organized. And I'm just talking over the work. So let's look at the example I asked you to do together really quickly. So we're going to set up a table like this. This is what you should have gotten for the molar mass of lithium chloride. You should have gotten 42.4 grams per mole. And make sure you put the grams per mole, otherwise, again, I'm going to take off half a point, and this is going to be a lot harder later on. And again, these are pretty easy because they're set up to have 1-to-1 ratios. Okay, let's make this a little harder. Let's look at the chemical, which is CO2. So now let's look at carbon dioxide as up top. And you can see something's different, which is this 2 here, right? Now that 2 only applies to numbers it touches, right? This 2 only applies to O. It doesn't apply to the C, right? It's monocarbon dioxide. And we don't ever write the mono, but you get the idea. There's 1 carbon to 2 oxygens, or as the table would look like, something like this. So I've got my carbon dioxide in here, and getting the AMU of the unit wouldn't take long. I just need to use the periodic table, so let's do that. And now I just multiply across. 1 times 12 is 12, and 2 times 16 is 32. And that leaves me a molar mass of 44 grams per mole, as shown. Okay, I'm going to ask you to do SF6 here really quickly, and I'll set it up on the screen. Go ahead and pause the video now, and once you've got it done, check your work against mine. All right, so let's look at sulfur hexafluoride here for a moment. It's pretty much the same process again, except now I have 6 fluorines. Again, that 6 doesn't talk to the S. It only touches the F, and so the 6 only multiplies the F. So I'm going to take 1 times 32 because the AMU of S is 32, and the AMU of sulfur is 19, or really 18.989 or something like that. And what you need to do is take 6 times 19 and 1 times 32 and then add down. Again, don't forget the grams per mole. And at this point, you're saying, hey, this feels pretty much good. And you're pretty much right, except I can throw a little loop for you. And so let's look at this tin cyanide, SN parentheses CN parentheses 2. And I think you'll see the problem here really quickly. So hold tight while I change the font. So let's look at tin cyanide here, specifically tin 2 cyanide. It's S parentheses CN parentheses 2. And this 2 here obviously applies to the whole group of cyanides. Not just the N, not just the C, but both the C and the N. In other words, I can break this chemical apart kind of like this, where I have 1 tin 2 and 2 cyanide groups. That is, 2 Cs and 2 Ns. So if I break that into my table like I'm used to, it would go something like this. Notice that each element gets its own row. Don't try to make a polyatomic go into a row. If it's a capital letter, it gets its own row. Okay, so I said I've got 1 tin and 2 of each of the things in the cyanide group, like this. Now it's as easy as finding the AMU of each element using the periodic table. And now I just multiply across and add down, something like this. So you should get 170.7 grams per mole, which is the molar mass of tin 2 cyanide. Now I'm going to ask you to do a really tricky one, which is something along the lines of chromium 3 sulfate. If you get this one right on your own, you know everything you need to know about this topic, but I'm guessing you'll probably make a couple tricks up.
So try it, pause the video, and when you're done and you think you've got it right, go and replay it and watch me work it through with you really fast. All right, so here we go. Chromium 3 sulfate. I've got 2 chromiums, right? Because this 2 only touches chromium. And I have 3 of this SO4 group. Now this 3 means multiply, distribute 3. So 3 times 1 is 3, and 3 times 4 is 12. So a common mistake here is to write Cr2S3O3 or Cr2S3O7. Both of those would be wrong. The right thing needs to distribute, just like you've learned in math. So our table will be set up like you see here. Now I grab the molar mass of each thing from the periodic table, rounded to the nearest tenth for now, and I multiply across and add down. All right, so I set it up and we're done now. And this is tricky. If you got this one right, if you got 392.3 grams per mole, you are home free. Now, we are going to spend all of Monday in class doing this together as group work. Right now, I just need you to do the notes. That's it. You're ready. You come prepared. Again, if you get nothing else out of this, remember grams per mole is the unit and make a table. And if we can do those 2 things, we'll be in the right spot for Monday. Have a great weekend.